Okay, you guys, so this is just a review of the binomial distribution, right? So what we covered in class was that we will use binomial PDF whenever we have exactly a number, right? We will use binomial CDF if we have a range of values, right? So in other words, an inequality, that's basically what we were kind of working with, right? So inequalities, I think I misspelled it, right? Okay, inequalities. Okay, so what I made here, I went ahead and made up a problem about Walmart. So you can go ahead and pause the video, and then you can write it down if you want, or whatever you'd like to do. And then I'm gonna go ahead and go over it right now. Or if you want to go ahead and try it and to see if you really understand the binomial PDF and CDF, you can go ahead and do that. But I'm gonna go ahead and start doing it right now. So what we have is a defective item from Walmart gets returned about 33% of the time. If 10 items are returned, what is the probability that exactly 4 are defective? Okay, so I completely made this problem up. I don't know how many items are defective at Walmart or get returned. So we're just going to go ahead and do this problem. So the first problem is that what is the probability that exactly 4 items are defective? Okay, so we know that this is binomial because remember that binomial has to have 2 outcomes, right? And the outcomes have to be, you know, in this case, a success or a failure. In this case, we would either have a defective item or not a defective item. We also have to have the number of trials n. We know n is just equal to 10. So here we know that n equals 10. And we also need to know the probability of success. Well, in this case, our success is getting a defective item, which is 0.33, right? So this is going to be 0.33. Okay, perfect. So now we want to find the probability that exactly 4 are defective. Well, this one's just pretty easy because we just got to use exactly, which is denotes with binomial PDF. So we're going to use the probability of x equaling 4, right? Or x is a number of defective items, right? All we're going to use is just binomial, okay, PDF. And then in this case, we know what n is. N in this case equals to 10. P in this case equals to 0.33. And then x is equal to 4, right? Okay, so now we're going to go ahead and put that into my calculator. Now, I only have the emulator for the graphing one, so we're going to go ahead and use that one. So with those that have the TI-36, the directions, you should already have the directions, or they will be posted on Blackboard, okay? So the first thing that we're going to do is do second vars. Then we're going to go all the way down to binomial PDF. Right, so here it is. So binomial PDF, enter. Number of trials is going to be 10, right? Probability is just going to be 0.33. And then the x value in this case is going to be equal to 4. Okay. For those that don't have the stats wizard, right, you would just go ahead and copy it just like I did right here. Okay. So I'm going to go ahead and press enter, paste, and the answer is going to be 0.2253. So 0.2253. So 0.2253. So in other words, this is kind of approximately 23%. So there is a 23% chance that exactly 4 of those 10 returned items are defective. Okay, should be a 2. Okay. Now part B, what is the probability that less than 6 are defective? Okay, well, let's just write this as an inequality. So we want to find the probability, right, that less than 6. So less than corresponds with the less than sign. 6 is defective, right? So remember, if we look at less than 6, well, 6, am I including the 6? No. So it's going to be open circle, and we're going to shade everything to this side, right? So less than 6, right? So we want a range of values. This is going to be inequalities. So now we're going to use CDF. So this is going to be binomial CDF. Right? I'm just going to write bin CDF. The number of trials is still 10. The probability is still 0.33. And then x in this case, well, now we have to be very careful because remember, 6 is not included, right? So we have to go to the next number, right? It's not going to be 5.99 because we can have 5.99 defective items, right? So the next whole number will be 5. So I'm going to go ahead and put in 5, right? I'm going to go ahead and put that into my calculator, right? So I'm going to do exactly the same steps. Second vars, go all the way down to binomial PDF, CDF. enter. Number of trials in this case is still 10. Probability of success is still 0.33. And then the x value is now going to be 5. Enter, paste. And this is going to give us 0.93% about. So 0.93. Okay, or approximately 93%. So about 93% of them are going to be defective if it's less than 6. Okay, so kind of likely. Okay, what about more than 3? Okay, well, remember, more than 3, in this case, probability of x being more than 3 is going to be greater than 3. Now remember, what do we know about binomial PDF? Well, I'm sorry, about binomial CDF. It can only take values that are only less than, right? So we got to do 1 minus the probability of x being the opposite of that, which is less than or equal to 3. Okay? All right, so we're going to do 1 minus binomial CDF, okay? N hasn't changed, it's still 10. Then we have 0.33. Then x in this case, now remember that we have, now in this case, it's included, right? We're including the 3, so I'm going to put the 3 in here. Whoops. Okay, this should be a 3. Okay. So we're going to go ahead and put in second vars, right? Binomial CDF. Okay, everything is the same. The only thing that we are changing is that now that's going to be a 3. Okay, paste, and that's going to give me about 57%. So 0.57. Okay, or approximately 57%. Whoops, I'm messing up. Why am I messing up? Okay, I'm messing up because this is 0.57, right? This thing is 0.57. Whoops. Right here, 0.57. And now I gotta subtract it from 1. Oh, I almost forgot that. Okay, so 1 minus 0.57 minus 0.57. I don't know why I put this in the calculator. It's just gonna be 0.43. 0.43. Okay, that is the answer. Okay, so don't make the mistake that I was about to make, which is forgetting to subtract it by 1. Okay, and now the last one, expected number of defectives, right? Whenever we know the expected value of a binomial distribution, remember that that is just expected value of x, which is also equal to the mean, is equal to n times p, right? So n in this case is still equal to 10. The probability of success in this case is 0.33, right? So we're going to go ahead and take 10, multiply it by 0.33, right? And what I'm going to get is approximately 3.3. So we are expected to have approximately 3.3 defective items from the 10, okay? I didn't have this as a problem, right? But also don't remember that the standard deviation of a binomial distribution is equal to the square root of NP 1 minus P. So these are things that you don't need to memorize. Just make sure that you write them down in your cheat sheet. But this is basically what we talked about in binomial distribution. So hopefully some of you guys were able to remind yourselves about this.